Hi everyone, today I am going to explain about physics practical of second PUC. Here I have the concave mirror. Now I am finding the focal length of concave mirror. The mirror is coated with one side, okay, one side is visible. Here this is the lens holder or mirror holder and this is a screen. Here I am finding the approximate focal length of this given concave mirror. For that I am taking the window as the object and I am showing the image on the screen. Here for particular distance the image of the window is clearly visible and that distance is taken as the approximate focal length of this given concave mirror. Now I am setting the focal length. Here I am moving the uh, mirror holder and I am fixing the screen. Here image is visible here. Now it is a blur condition. Now it is clear, again blur. Okay, you have to set the desired range of the image. Okay, now it is clearly visible. You can see the image at here. Okay, this is the image of a window. Okay, yes, here I am measuring the distance between screen to mirror holder. Here the distance is the total around 17 centimeter is there. Here 17 centimeter is the approximate focal length of a given concave mirror. Okay, you are visible here. Okay, 17 centimeter, this one. Yes, this is the approximate focal length. Now I will show how to measure the readings in a optical bench. Now I am showing here the instrument optical bench. This is the optical bench used for measuring the focal length of concave mirror. Here I taken the parallax, I removed the parallax. Here the object pole and image pole is coincided. Okay, like that you have to set it in a proper way. Here the focal length is, approximate focal length is f equal to 17 centimeter. We have to make it double. 2f means 34 centimeter. Okay, and I am taken here the approximation of certain image distance. U means object distance and v means image distance. Here object distance is 28, 27, 26. First we have to set this distance. Okay, then for particular distance we have to measure the image distance. Here first I kept 28 centimeter as the object distance. For this object distance I am taking the image distance. Okay, now I will show how to measure the image distance. Now it is a u. I kept 28 centimeter as a object distance. Okay, for this object distance now I am measuring the image distance. Yes, you have to consider from here to here. Okay, here the image is visible in the mirror. Okay, as a coincidence of object pole as image pole. Okay, you have to measure this image distance now. Okay, here this is the object pole and this is the image pole. Okay, okay, this is the experimental setup. Okay, here I am finding the image distance now. This is the object distance u. Okay, it is the distance between this mirror to this object pole. Okay, and from mirror to here this is the image distance. Okay, now I am finding the image distance. Already I kept the image in a proper way. Okay, here total is 43 centimeter. You are able to see here 43 centimeter. Okay, here for 28 centimeter is the object distance. For this object distance the image distance is 43 centimeter. Next I will do for second reading the distance. I am decreasing the 1 centimeter distance. Okay, 27 as the object distance. Now for this object distance I am finding the image distance. Okay. Now I am showing the another distance here. I kept it for 27. Okay. Now it is for 27. This is the object distance. For this object distance I am finding the image distance now. The image distance is now 44 centimeter. Okay, 1 centimeter has been increased. Okay, this is 44 centimeter. Now it is 44 centimeter as a image distance. Next reading we have to do the 1 centimeter variation, and for that variation you have to find the image. Okay, it is 45 centimeter, like that. In all the readings you are observing the like that coinciding nature, that you have to observe the object as image pole. Okay, this is the parallax, means object as object and image pole. You have to observe like this. Okay, this is the heading focal length of the concave mirror. Here this is the aim of the experiment: determination of the focal length of the concave mirror by finding the values of V versus different values of I. Okay, yes, here apparatus. Okay, these are the apparatus required, and this is the principle of the experiment. Okay, and this is the procedure of the experiment, how we can take the readings in the optical bench by varying object as well as image distance. And next here, okay, these are the steps of the procedure. Okay, and next yes, this is the diagram of the experiment. Okay, this is the mirror and this is the u, means this is the object pole. Okay, distance is u here. This is the object distance, and this is the image pole. Okay, here you are observing coinciding nature, and this is the v, image distance. Okay, and next the formula here, f is 17 centimeter, 2f is 34 centimeter. Formula is f equal to uv divided by u plus v. This is the formula for finding the focal length. Okay, here okay, this is a tabular column. One of our student taken the readings here. Object distance u 28 centimeter. For that object distance, the image distance is 37, and focal length, by using this formula, the answer is 15.93. and next object distance is 27 centimeter. For that image distance is 38 centimeter. Focal length is 15.78. in the same way they took 5 readings. Okay, by different object distance and different image distance. Okay, after that you have to do the mean value, means here 5 trials they taken. You have to add the focal length of all 5 trials and divide by 5. Okay, then the answer becomes 15.23 here, and this is the result. Okay, this is the calculation part, how the calculation taking place by the formula of focal length. Okay, yes. Next, the final part is result of the experiment. Here, okay, focal length of the concave mirror is f equal to 15.56 centimeter. Your answer should be equal or nearly equal to the that approximate focal length. Here in this experiment we taken the approximate focal length as 17 centimeter, and the answer is near to 17 centimeter, that is 15.56 centimeter. Okay, thank you.